Math 2, Unit 11, Lesson 7. Today we're talking about factoring special cases. Yes, pretty exciting stuff for sure. Okay, so you should be on page 685 right now, and you have your essential understanding.
Got it.
We talked about this briefly yesterday, okay? But for every, let me see here. I wanted you to notice that, do you see how you have a squared and a b squared? When your first and last terms are squares, and then you have your middle term, these will normally factor to be perfect squares. If this number right here is a plus, when you split them up, you get pluses in between both of the parentheses. If right here you have a minus, both of your parentheses will be a minus. Okay? We are just going to jump into examples now. Okay? So on page 686, do you notice how the front term's a square?
Yes.
Can I write the back term as a square?
Yes.
Yes, 3 squared, x squared, and 3 squared. This is a positive, right? So therefore, it's going to make a perfect square. You are correct. So we're going to make our two parentheses. X goes into the front of both of them. So we're splitting up the squares in the front. And we do the same thing. We split up the squares in the back. So we're going to write a 3 in the back. And both of these will become a plus. Now, you could factor this the same way as we did other problems. But remember on the quiz yesterday how large some of the numbers were? And so if you notice that they're both squares, this can be your shortcut, okay? And so we'd actually end up writing this, since they're the same, is x plus 3 squared. Okay, notice here on B, and if look here, and just to double check, notice how 3 plus 3, that adds to be 6. And 3 times 3 adds to be 9, okay? And if we use the box or distributive method, we'd get back to that original problem. Okay, on B. First term is already a square. We have x squared. How do I write 49 as a square? 7 squared. Do you notice here that this one has it's a negative. If you can't see it, there's a minus there. So when I write this, we're going to make our parentheses. We split up our x's in the front of both of them and our 7's at the end. And this time, both of them will be negative. And so this will actually be x minus 7 squared. Okay, I want you to try practice problem number 1 on your own. Still on 686. Okay, so how do I write 25 as a square? And so that means that we make our parentheses, and we're going to have a v in front of both of them and a 5 at the end, and both of the signs will be good. So we're going to write that as v minus 5 squared. Could I skip this step and just write it this way? Sure. Yes? If this one is a subtraction, both of them will be subtractions. If this one's an adding, both of them will be adding. The reason is, even though this is subtraction, because a negative 5 times a negative 5 still makes a positive 25. So when you have perfect squares, this number at the end will always be positive. And so if you have a minus there, that means that they both add to be a negative number. And if it's a plus, then both of them will be plus. Okay? All right, so notice 2 is slightly different. If we are factoring this the way we've been factoring, there's no GCF here. You would have to go over by 4 and get 81. That is a large number. Now, could you guys do it? Yeah, you totally could. But it just takes a little bit of time. So, if you notice that your front term and your last term are squares, you can use this shortcut, okay? And so, could I write 4 as a square? Yeah. 4 is 2 squared and r squared. And can I write 81 as a square? Yes, what is that? 9 squared. Now, this only works if you're able to do both of them as squares. If you can't, then it's not a special case and you have to do what we've been doing previously. Does that make sense? Okay, now, so I make my 2 parentheses. What's going to go in the front of both of them? Very good. And what goes at the end? 9. And will these be pluses or minuses? And how do you know? Because that middle term is positive, okay? So we get 2r plus 9 squared. Questions? Okay, turn to page 687. Or move your eyes. Okay. Factoring to find a length. So it says you're building a square patio. The area of the patio is this equation. Find what is the length of one of the sides of the patio. So, big numbers, right? Could I multiply over by 6 and factor? Yeah, I could. But might not be super fun. Okay, so what do we notice on this one? Can 16 be written as a square? What? 4 squared, m squared. And can 81 be written as a square? What? Very good. Okay, so what will my square end up being? Very good. Do we have questions? Okay, still on 687, problem number 3. I would like you to do this one on your own. I'm going to give you approximately 20 seconds because I think it'll take you that long. Give me a thumbs up once you're done. Good. Okay. Good. Fail. Good. Someone doesn't know how to follow directions. Okay, I'm waiting for you. I'm waiting until you give me that thumbs up that you're ready. Thank you. Fail. Good? Okay. Can I write 100 as a square? Tell me what it is. 10 squared, and then that is an r squared. How do I write 121 as a square? Okay, and are these going to have pluses or minuses? How do you know? Because the middle term is negative. Very good. And we're done. Number 4. Give me a thumbs up when you're done. Okay, good, good, good. Good, thank you, thank you. Fail. Good, thank you. Good, thank you. Always pushing the limits. Nope, not acceptable. And don't go to a different finger. Okay. All right. Okay. How do I write 25 as a square? 5 squared, and I still have an r squared there. How do I write 9 as a square? 3 squared. When I write this one, what's going to go in the front?
5.
And at the end? Good. And it's a plus because?
Plus 9.
And if I were to do my box or FOIL method, I could multiply this out and it'd go back to my original problem. Correct? Okay. Page 688. Here we go. Something new. Equally exciting, though, let me tell you.
Oh, really?
Exciting. Yes. Okay. This is differences of 2 squares. We actually talked about multiplying this back, I think, in 11.1. Notice here that we have 2 squares, but do you see how there's no middle term?
Yeah.
So we have just 2 squares. Difference, guess what difference means?
Multiply.
It means subtraction. Okay? Now this only works if you have a subtraction sign between 2 squares. Okay? all you do, same as we just did with our perfect squares, is that you separate your squares. Separate the squares in the front, the squares in the back, and one gets a minus and one gets a plus. The reason is because if the middle terms will cancel out. If one is a negative 3a and one is a positive 3a, those cancel out and you eliminate the zero or the middle term, okay? And so, but it will only work if you have a subtraction sign. If you have an adding sign, it cannot be factored. Okay, so going down here to got it problem A, I need to first write these as squares. So we already have v squared. How do I write 100 as a square? 10 squared. Okay, so we make our two parentheses, we separate the v's, we separate the tens. One gets a minus or plus, and one gets a plus. It doesn't matter which one gets the minus, which one gets the plus. Remember, order of writing parentheses doesn't matter, okay, as long as you have both of them there. Okay, if you are doing, what?
That's the answer?
Yeah, this is it right here. Yep, and I just want to show you that, just like on the last one, if I use the distributive property to multiply it through, v times v makes v squared. V times positive 10 is positive 10v. Negative 10 times v is negative 10v. And negative 10 times positive 10 makes negative 100. See how these middle terms, one's a positive 10v, one's in a negative 10v? They cancel out, and I end up with v squared minus 100. Okay? All right, next one, B. How do I write 16 as a square? So we make our two parentheses. What's going to go in the front? S. What's going to go in the back? And one gets a, and one gets a plus. You're done. Can I write those as a square? No, because they're not the same, right? So this one you have to write out both parentheses because one has a minus, one has a plus. They are not exactly the same. Okay, on 688, problem number 5 is your turn to try. Okay? Give me a thumbs up if you're done. Awesome. Okay. How do I write 12 as, okay, I just told you. 12 squared. So we split up our W's. We split up the 12s, and what goes in the middle? Will this work if this number is a plus? No, it has to be a minus. It has to be difference. It can't be a sum of squares. It has to be a difference of squares. Okay, page 689. Okay, got it, problem A. This one is more complicated because there's more numbers, but you guys are so smart that this is going to take you 10 seconds. Ready, set, go. Give me a thumbs up when you're done. Awesome, good, good. Okay. All right, so what do I do first? Write them as squares. Always start by writing them as squares. How do I change 25 to a square? So we get 5 squared, d squared minus. So we make the parentheses. What goes in the front? And then a minus 8 and a. Awesome. Okay. Page 689, let's just do problem number 8.
I think our whole test should just add you.
Yeah, you like that? Shh. Good. Yeah, let me know when you're done. You're doing number 8. Thank you, thank you. Good. 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 How could you check if a number is a square if you're not sure? How do you put it in the calculator? Yes. So if you're not sure if a number is a square, all you do, Hannah told me, is that I go second and I press my square root button and then I can type in 400. And I press enter.
Hannah didn't tell you.
Oh, what? I thought you didn't do 20. 20. So 20 is a square. I thought you told me.
Oh, she did.
Whoever told me, oh, was it Shelby? Sorry. Credit to Shelby. Good job, Shelby. Okay. 9, 3 squared, n squared. And then we have a 20 squared. How will I end up writing this one? Perfect. Okay. Questions before I move on? Yes. Well, I did use 2 parentheses on the other ones too. It's just that the parentheses were exactly the same, and so I could end up writing them as a square. Okay, does that make sense? These are not exactly the same. One's plus, one's minus, so we can't do that. Okay, all the little side conversations need to stop, please. Okay, we're turning to page 690 now. It is a little different. But if you guys know how to read, you are going to be able to figure out what's different about it.
Dang it.
What is different about this? You have to first take out a GCF. But whenever we're looking at problems, shouldn't we always look for GCF first? The answer is yes, always. Okay, so looking at this problem, do you notice a GCF? 12 is the GCF. 12 goes into each of those numbers. So I'm dividing each of these by 12. What am I left with?
1 and 4.
T squared minus 4. Now, this is where you're like, can I factor this further? Can I take this further? And the answer is
Definitely not.
yes. Okay? Because this is already a square. Can 4 be written as a square? Yes. We have t squared and a 2 squared. So my final answer, I keep that 12 in front because that's my GCF. What goes in the front of both the parentheses? T at the end, a minus 2 and a plus 2. And I can't, that's it. It's done now.
Where did 12 come from?
Are you being serious?
Serious. Where'd you get that 12?
Okay, so at the original, we're checking for the GCF.
Okay, good.
Okay,
It's just the GCF.
yes. So 12 is our GCF. Okay, B. Is there a GCF on B? 3 is the correct answer. So that means we are factoring out a 3, which means we divide each of these terms by 3 and write it in here. What am I left with? 4x squared plus 4x plus 1. Now, are these squares? Yes. 4 can be written as 2 squared, and we have x squared, and 1 is 1 squared. Okay, how does this one end up being factored? What goes in the front of both of them?
2x.
And then at the end? And see how we have the middle term on this one? That's when both of these have to be the same sign. It's only opposite signs when they're 2 terms. So both of these are going to be plus. Good. And I could also write that as 3 and then 2x plus 1 squared. Questions? Okay. We are going to try another one. Number 9. Number 9. We're going to do 9 and 10. Number 9 on your own. What's your GCF? Okay, are we good?
No.
Okay, I'll wait. Anybody else one more time? Are we good? Okay, Kate, those are the only what matters, so here we go. All right. I'm totally kidding. Okay, what's my GCF? 3. Okay, which means we divide each of these by 3. What is left over? Okay, now, once you take out your GCF, now we write them as squares. What is 9 as a square? 3 squared and W squared, and the 4 is 2 squared. So we still keep our 3 in front. I'm going to make the 2 parentheses. We have what in front? 3W and 2 at the end. Now in this one, are they going to be both be minuses, both be pluses, or one of each? Why is it one of each? There's no middle term, right? And so you'd want your middle term to be canceled out, so you'd need one to be minus and one to be plus. That is the correct answer. Okay, number 10. Okay, are you guys ready? I'm waiting. Okay, what was the GCF at least? And we know it's 5 for sure, at least, right? Because both numbers end, if you have numbers that end in zeros or 5s, we know it's divisible by 5. Okay, so we divide these by 5, and what are you left with?
16 squared minus 4.
Okay. You guys know those, right? But if you didn't know if those were squares, we could use our calculator. We could plug them in and check, right? I know. Also, I don't even know if you guys know this, but on the wall back there by the calculators, there's a chart of all the squares from 1 to 25. You could take a picture of it for quick reference for your homework this weekend. Okay. All right. Again, you didn't have any last. You guys, I don't know if you guys know this, but you're in high school now. Welcome to the real world. Oh my gosh. What's going to go in front of both of them? 5. No. Oh yes, you're right though. 5 first. Then 4G and then one gets a. There's your answer. Any questions?